Welcome to Lesson 5 of Unit 5. And in this lesson, we're going to review the concept of the least common multiple, the LCM. So there are various ways that we can determine the least common multiple. In grade 7, though, we're going to use the idea basically of skip counting. So we're going to consider actually right now the multiples of 4 and 6. So the multiples of 4. So I start with 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, and I could keep going, and that's why we have the ellipsis there. But we're going to stop at 52 for now. Now let's look at our multiples of 6. So 6, 12, 18, 24, 30, 36, 42, 48, 54, and again, the ellipsis tells us we could keep going, but we'll hold our list right now from 6 to 54. So what I want us to look at now, says in the lists above, which are not all-inclusive, which means again that these lists can continue forever, we want to look at the numbers that appear in both lists. So let's have a look. Well, I have a 12 and a 12. I have a 24 and a 24, 36 and 36, 48, 48. So the 12, 24, 36, and 48, these are what we call common multiples. But notice, we are ultimately interested here in the least common multiple. So the smallest common multiple is 12. So our LCM is 12. So let's look at a couple of examples. In the first example, we're asked to determine the LCM for 3 and 5. So let's first of all generate the multiples of 3. So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. How far do we have to go? Not quite certain, but I'll list off a couple of more, put a comma, put in my ellipsis to show that this can continue on, and we're going to start on the multiples of 5. And hopefully, we'll notice a common number in both lists. So let's see. So 5, 10, nope, nothing in common yet. But when I put down the 15, I can stop. Because now I have a number that's common in both lists. So what that means, 15 is the LCM for 3 and 5. Let's look at another example. So the least common multiple for 4 and 8. Okay, multiples of 4. Skip count. 4, add another 4, add another 4. And I'm going to stop there. Now I'm going to do my multiples of 8. And guess what? I only need to write down one number because 8 is common to both lists. So the LCM for 4 and 8 is indeed 8 itself. So let's make a link now to operations with fractions. Obviously, we're looking at this concept for a reason. Well, recall that in order to add fractions, we must have a common denominator. So what happens if our denominators are different? So if we're given two fractions with different denominators, what do? Well, we have to create a common denominator for all fractions involved in order to be able to add them. So what we're going to do here, we're going to determine what's called the least common denominator. So instead of LCM, now we call it LCD. D, of course, for denominator. So my numerators here I'm not going to be concerned with. I'm just curious about if I have to generate a common denominator for 10 and 12, well, that's going to be the same idea of me getting the common multiple, the least common multiple for 10 and 12. So we're going to do it by skip counting. I list off some multiples of 10. 10, 20, 30, 40, 50, 60, 70. I'm going to go up as far as 80. And hopefully that'll be enough. So now I do my multiples of 12. 12, 2 12s, 3 12s, 4 12s. Nothing in common yet, but when I do 5 12s, I get a 60. And there's a 60 in my top list. So the LCD, the least common denominator, for my two fractions will be 60. And now I'd like you to proceed to the activities for Lesson 5.